altitudes of a triangle are concurrent. That means it will meet at a point. Draw perpendicular from the vertex to the opposite side. So this is the altitude. So AD is an altitude, BE is another altitude, and CF is another altitude. All will meet at a point. So they are concurrent. Altitudes of a triangle are concurrent. First, let us consider two altitudes. AD is one altitude, BE is another altitude. Then that will meet at a point O. Then join CU, extend it. Then if you can prove CF is perpendicular to AB, then we can prove that altitudes are concurrent. Now take O as the origin. So OA vector is A vector, OB vector is B vector, OC vector is C vector. Now AD is perpendicular to BC. AD is perpendicular to BC. When AD is perpendicular to BC vector, OA will be perpendicular to BC. AD, OA. So, when AD is perpendicular to BC, OA is perpendicular to BC. When two vectors are perpendicular, dot product will be 0. So we can write OA vector dot BC vector is equal to 0. So OA vector is A vector. BC vector can be written as position vector of C minus position vector of B. So BC can be written as C minus C vector minus B vector. Now you remove this bracket. So A dot C minus A dot B is equal to 0. Similarly, BE is perpendicular to CA vector. BE vector is perpendicular to CA vector. When BE is perpendicular to CA, OB is perpendicular to CA. Two vectors are perpendicular, dot product will be 0. OB vector dot CA vector is 0. Position vector of B. So OB vector can be written as B vector. Then dot CA vector can be written as position vector of A minus C is equal to 0. Remove this bracket. B vector dot A vector minus B vector dot C vector is 0. Then dot product is commutative. So B vector dot A vector can be written as A vector dot B vector. Now add these two equations. So you can see here minus A dot B, here plus A dot B. So this will get cancelled. Then A dot C minus B dot C. C vector common, so you take it outside. So this can be written as A vector minus B vector dot C is equal to 0. Now A vector minus B vector. So this is A vector is position vector of A minus B vector. B vector is position vector of B. So this can be written as AB vector because position vector of A is A, position vector of B is B. So A vector minus B vector is BA vector. So BA vector minus BA vector dot OC vector. BA vector dot OC vector is 0. When dot product is 0, vectors are perpendicular. So BA vector is perpendicular to OZ vector. BA vector is perpendicular to OZ vector. BA vector is perpendicular to OZ vector. So we can write CF, OC. BA vector is perpendicular to OC. So we can say CF, OC, CF. So OC. So CF, when OC is perpendicular to BA, CF will be perpendicular to AB. So when CF is perpendicular to AB, we can see altitudes are concurrent.